Hello everyone. I welcome you all to the fifth session of JCL programming. I hope till now you have learned so much about the JCL programming, and I'm also assuming that you are practicing, you are reading all the topics that we have learned till now. Okay, so let's start with the fifth session. Okay, so agenda of this session is what we have learned in the last session. So we'll be having quick recap of what we have learned in the last session. Then we will be deep diving into the different types of record format that we have discussed in the last session. So we have discussed what are the record format we have for if we are creating any file. So we have variable, we have fixed block, we have variable block, then we have underline as well. So this is all about the record format that we will be discussing in this session. And after that, we will be discussing what are the DD statement that we have for the Instream dataset and SYSOUT dataset. So let's start with this first topic, which is last session recap. So in the last session, we have learned about the what is catalog facility. So to keep the track of hundreds of files and thousands of dataset, we have the facility, we can say we have facility that actually catalog all the records or the location of that file. So that is all about the catalog facility. So when you want to access the file, you don't have to know the volume serial number of that file contains, and the system can look it up in the catalog for you. So basically there are two types of catalog that we have discussed in the last session. One is master catalog and another one is the user catalog. Each system has one master catalog along with unlimited of user catalog. So user catalog is all about whatever the data set you will be creating. So all that comes under the user catalog. And after that, we learned about the DD statements parameter, which is DS name, DSN, DS name, all those. So what is DS name and how it is very important to provide the whatever the file you need for that program to process. So that all come under the DD statement and DLN DS name. After that, we learn about the example of DD name syntax. So what should be the syntax of the DS and DS name? And after that, we learned about the disposition parameter, like how to specify the disposition parameter. If you are creating new file, then we should use a new. Then we have old, we have share, we have modified. So disposition parameter has three positional sub parameter. First one is the status. That means status of that file, whether it is new, whether it is old, whether it is in the sharing mode, that you can also access the same file and another person can also access the same file. That is regarding the sharing. And another one is the modifier, that you want to add the records to that particular file. So that is all about the status. And the next one is the normal disposition, and another one is the abnormal disposition. So normal disposition specifies what the system should do with that particular data set or with that particular file if the job step bends abnormally, sorry, normally. So if that particular step is successfully executed, so what is the next process? So what should be the next operation for that particular file? So we have keep option. That means you can keep the file. Another one is the delete. You can delete the file. Another one is the catalog file, or you can also uncatalog that file as well. And also there is one of the facility which is pass. Like if you want to use the same file for the subsequent job step, then you can mention pass as well. But in abnormal disposition, that is something if your job step fails, and so what should be the next action for that particular file? So those are same: keep, delete, catalog, and catalog, but we don't have option as pass. So that is all about disposition parameter. Then we discuss the syntax of disposition parameter. Then we discuss about what is unit, what is volume. Then we discuss about the syntaxes of those unit and volume parameter. Then we deep diving into the space parameter, like if you are creating any file, what are the space parameter you need to give. So we have as, space equals to unit. That means specifies the unit allocated for that particular data set. So we have track, cylinder, block length, record length. Then we have primary quantity, secondary quantity. Primary quantity specifies the number of unit to be initially allocated to that particular file. So and after that, we have the secondary quantity specifies the number of units to be allocated to each uh, secondary extent, we can say. Yes. And another one, we have the directory specify the number of directory block to allocate for partition data set. So that is all about the space parameter. Then we discuss about the DCB parameter, which is data control block parameter, where we discuss the syntax, where we have the organization. We can have the PS, which is physical sequential. Then we have the PO, which is partition. We have DA, direct. We have IS, index sequential. Then we have the record format, which specifies the format of the files record, where we have fixed length, we have fixed length block, we have variable length unblock, we have variable length block, and we have undefined as well. So that is, I think, all about that we have discussed in the last section. Okay, so today's topic is the different types of record format we have. So traditionally, ZOS datasets are record oriented. In normal uses, there are no byte stream files such as found in PC and Unix system. ZOS Unix system has a byte stream files, and byte stream function exists in other specialized areas. These are not considered to be traditional datasets. So in record format, we will be having fixed length, variable length. So what are those meaning? Like if we are defining fixed length, if we are defining fixed length block, what is variable length, what is variable length block? So how you decide? So we will be learning that. In ZOS, there are no new line or carriage written, and line feed character to denote the end of the record. Records are either fixed length or variable length in each dataset. When editing a dataset with ISPF command, for the example, each line is record. So yes, so in our data set, so for example, in ZOS system, you are creating any PS file or any partition file. So each line is a record. So we have the record length. So as per your requirement, you mentioned the record length, and whatever we have in that particular line is our record. So each line is a new record. So based on that, you specify the record length. So first one is the fixed. So fixed means it word defined. So each record has a fixed length, but there is no blocking. Records are written sequentially one by one. So in the next slide or coming slide, we will be having one diagram where it will be easy to understand what is fixed. So just to understand, fixed, each record has a fixed length, but no blocking, because it is not a block. It is just fixed, and records are written sequentially one by one. So if you're writing one record, then after on the next sequential line, we will be having the next record. So it is fixed. The next one is the fixed block. So we have the fixed record length, and we are using those data in the fixed size block. So that is what fixed block is. So in fixed, we are having the record length as a fixed, but we are storing that record or that data in the fixed size block. That is why we called it as a fixed block. The records are stored in fixed block, which can improve the input output performance by minimizing the number of read and write operation. Several logical records are combined into one physical block. Yes, so we are writing whatever the record we have, and we are defining the block size as well. So based on that, several logical records are combined into one physical block. This can provide efficient space utilization and operation. This format is commonly used for fixed length records. Block size is physical block size written on the disk of F and fixed block record. For variable block and undefined record, it is the maximum physical block size that can be used for the dataset. So to improve the efficiency, to improve the space allocation, and to improve the operation performance, mostly we use the fixed block uh, record format for our files. So that is all about the fixed block. So we have the record as a fixed length and data is stored in the fixed size block. The next one is the variable. So as the word it's telling itself, records have the variable lengths and there is no blocking. This format has one logical record as a one physical block. And a variable length logical record consists of the record descriptor word, which is RDW followed by the dataset. So in variable record length, first we will be having RDW, and after that we will be having the our whatever the data or the data length. The record descriptor word is 4-byte field describing the record. The first 2 byte contain the length of the logical record, including 4-byte RWD. The length can be from 4 to 760 bytes. All bits of the third and fourth bytes must be 0 because other values can be used for the span records. So in variable record length, first we will be having RDW, which is record descriptor word, and followed by our data. And it is a 4-byte field describing the record. The first 2 bytes contain the length of the logical record. The next one is the VB, which is variable block. Records have variable lengths and those are stored in the block. So it is same as the concept as a fixed block and variable block. In the fixed block, we have the length of that particular record as a fixed, but in variable block, we have the length of the record as a variable, but both are stored in the blocks only. The records are stored in block, which can improve the input-output performance by minimizing the number of read and write operation. This format places several variable length records, each with an RDW in one physical block. So yes, in the previous slide, we discussed about the variable uh, length record. So it is having, firstly, we will be having RDW, and after that, we will be having our actual record. So this format places several variable length logical record, each with an RDW in one physical block. The software must place an additional block descriptor word, which is BDW at the beginning of the block containing the length of the block. So in our block size or in variable block, we also having another concept, which is block descriptive word at the beginning of the block. So we will be having that BDW, and after that we will be having RDW, and after that we will be having our record length. And the next one is the undefined. This format consists of a variable length physical record block with no predefined structure. So there is no structure for that particular file. That's why it is marked as undefined. Although this format may appear attractive for many unusual applications, it is normally used for only for executable module. So if you are using any executable module, then undefined dataset can be a useful, because normally it is only used for the executable modules only. Okay, so this is the diagram that can explain what are the types we have. So different types of record format. So first one is the F, that means it is a fixed record. And here we are not having any block size because it is just fixed. So this is the record, and all records are having the fixed length. So that is why this is the first record, this is this second record, this is the third record, this is the fourth record. So here the one logical record is equals to one physical block size or one physical block, because there is no you can say block combined. So that's why block size is equals to record length. So whatever we have in the block, the same we will be having the record length. But in the FB, which is our fixed block record, so fixed length, and we will be also having the block record. So here the block size is the multiple of n into record length. So whatever the block we will be having, so we will be multiplying those with the record length, and then we will be having the block size. So in this example, we are having one record, two record, and three record. So all three records are in the same block size. So that's why block size is equals to n into the record length. So after that, we can have the block size of that particular record. So here also we are having three records, and after joining three records, we will be having the block size of that whole record. So that is regarding the fixed block. And the first one is only the fixed records. Okay, the next one is the variable. So in the variable, we are having the variable length. As you can see, the record length are not equal. But in here, in the fixed length, we are having the equal length for all the record. But in variable, we don't have the equal amount or the equal length for the records. So as you can see, the third one is very big, the second one is small, and the first one it's in between that. So here also the block size is greater than the record length. Why? Because we are having the RWD as well. It is always greater than equal to, so block size is greater than equal to the record length, and record length is consist of RDW, and RDW is always 4 bytes, and after that we will be having the record. So here you can see for every record at the starting we will be having the RDW, and after that we will be having the record length. So record length is always 4 plus whatever the data length you have for that particular variable length record. So that is regarding the variable. The next one is the VB, which is variable length block records. So here you can see length is different for that particular record because it is variable. But if you can see here, we are having BDW, and after that we are having RDW. So that means we are having the RDW as a 4, and after that before that we are having the block as well because we are having BDW. So here we are having three records, and at the starting of each block we are having BDW, and by joining them we are getting the block size of that particular record. So that's why here we have written 4. 4 means we are having RDW at the starting, so that is why it is 4 plus n into record length. So that is all about the variable block. The next one is undefined record. So that means there is no defined internal structure for access method. As you can see in the diagram as well, we are having a random length for that particular record. There is no internal structure for those to access the file. And also a record descriptor word and a block descriptor word are each 4 bytes long. So whenever you are working with our variable length or variable block length records, so just keep in mind both RDW and BDW are 4 bytes long. So I hope the concept of how fixed block, how variable block, and how undefined uh, record format looks into when you are assigning them to a particular file. So I hope this diagram explains what we have learned till now. Okay, so this is one of the example. We have example of here we have the record format as a fixed block. So data set with fixed block and a record length as a 25. Data set with record length of 25 is block. And for a fixed block data set, the record length tells you the length of each record in the data set. All the records are same length. The first data byte of the fixed block record is in position 1. A record in an fixed block data set with record length 25 might look like this. Okay, so we are having the record and which is 25 bytes long, and how it looks. So in the first three position, we have the country code, which is USA. And after that, we have the state code, which is CA. And after that, we have the city, which is St. Joe's, padded with 12 blanks on the right. So we have the 25 length. So first three are USA, and after that we have 4 and 5, which is CA. And after that, 6 to 25, we can have the city. So whatever the data left after giving the city name, those will be padded with the blanks on the right side of that particular record length. So we have one line of 25 record length, which is of a fixed block. And for each record, first three are USA, 4, 5 are CA, 6 to 25 are a city name, and after that we will be having whatever the remaining position as padded as a blank on the right side of the track. Okay, so the next one is the variable block with record length as 25. And in variable block data set, records can have different length. Yes, we have discussed in variable block records can have different length. The first 4 bytes of each record contain the RDW, and the first 2 bytes of RDW contain the length of that record in binary. The first data byte of VB record is in position 5. After the 4 byte RDW in position 1 to 4, a record in VB dataset with 25 record length might look like this. Okay, so the first two is length in RDW, which is in binary. And after that, in the position 3 to 5, we have zeros in RDW. And after that, we have 5 to 7 position as a country code, and after that we have 8 to 9 as a CA, which is our state code, and remaining 10 to 17 we have the city. So that is regarding the variable block. So in the first two position, so first 4 bytes are basically RDW, and first 2 bytes contain the length of that particular record in the binary. And after that we have zeros, and after that our actual record gets started. So from 5 to 7 we have a country code, and from 8 to 9 we have state code, and from 10 to 17 we have a city. So this is how the variable block record format looks like. Okay, so the next one is the DD statement for in-stream dataset. So in the previous lecture, we have discussed what is in-stream dataset and what is SYSOUT dataset. So how you write the DD statement for those, we will be discussing in those concept in this in this slide. You can include in-stream dataset along with JCL statement in a job stream. JES will copy the in-stream data to a spool volume from which your processing program can retrieve that data as it execute. So let me explain. So you can provide the data, in-stream data along with JCL statement, and our JES job entry subsystem will copy that in-stream data to our spool volume from which your processing program, whatever the programs you are doing, will access that data when program is executing. So that is how you can transfer the in-stream data to particular program, and that program will catch that data from the spool and it will execute the program by using that data. The program will treat the in-stream data as if it comes from a standard sequential file with 80 character records. The end of in-stream data is marked either a delimiter statement, the next JCL statement in column 1 and 2, or specifically defined delimiter statement specified by the DLM parameter. If the in-stream data contain JCL statements / in column 1 and 2, the data parameter must be used. So for the in-stream, whenever you transfer any particular data to that particular program, then program will treat that in-stream data as of it is coming from the sequential file of 80 bytes. So that is how you can transfer the in-stream data set to that particular program. Okay, so this is the syntax of DD statement of in-stream data set. the syntax of DD statement. So it is simple, forward slash DD name, DD. Either you can have a asterisk or data, or you can have as you can also have a DLM parameter. So what is asterisk and data? It indicate that in-stream data follows. If you code an asterisk, the next JCL statement ends the data. If you code data, you must include a delimiter statement to end the data. And what is DLM? DLM specifies the character that identify the delimiter statement. If omitted, slash asterisk is the default. So this is the syntax. So in the coming example, you will get the better idea about how to code the DD statement for in-stream. Okay, so there are three example of coding in-stream data. This is the example one. So here we are having DD asterisk and we are passing some values. So what are those values? So example one shows the most common way of coding in-stream data. In-stream data first, we are having DD asterisk statement indicate the record that follows are the data for the in-stream data set. The DD name on the DD asterisk statement associate the in-stream dataset with the file preferred by a program. A dataset name isn't required because the file will reside in the JES pool space that we have already discussed, job interest subsystem pool space. And following the data, a delimiter statement forward slash star marks the end of the data. And the delimiter statement is optional in this case. If you omit the next JCL statement, indicate the end of the in-stream data set. So in this example, if you can see, so we are having asterisks and we are passing some three values. So those three values will be going into your program, whatever the program you are writing before this exact DD statement in the exact statement. So for that particular program, you will be using this three value as an input record, and that program will process this three input record, whether it is having some uh, reading from the file or processing that data and writing that data into another file. So whatever that operation, we are passing these three values to that particular program, and that program is executing by using these three records. So this is the example one. So in the example two, we are having DD as a data. We are having DD as a data. So here we have step one exact, we are providing program name. And after that, we are having this is out equals to A. So what is this example two? Since a subsequent JCL statement marks the end of the in-stream data set, what do you do if you want to include JCL statement as a part of in-stream data? You use the DD data statement. So whenever you want to include JCL statement as a part of in-stream data, you use the DD data statement. When you specify the data parameter instead of an asterisk, you must code a delimiter statement to mark the end of your data. That way, JCL statement can be read as a data. So example 2 shows how the DD data statement works. So here in the example, you can see we are marking as a delimiter also, and we are providing the JCL statement into the in-stream data set, in-stream values. And the next one is the example 3, where we are having data and also we are having DLM parameter. So DLM parameter lets you change the two character code used to represent the delimiter statement. You might need to do that if your in-stream dataset has a record with asterisk in column 1 and 2. Although that's an unlikely situation, it is possible. So example 3 shows you how to use the DLM parameter. So this is all about the three examples that we have for the in-stream data set. Next, we will be discuss what is SYSOUT data set. So how you can code the DD statement of SYSOUT data set. Programs that produce reports typically use the SYSOUT parameter in their DD statement. JES2 and JES3 allow a program to produce SYSOUT dataset that are allocated in JES pool space before they are printed. Yes, so when you are working on any program, That is typically a report generation program. Then sysout plays a very important role, that whatever the sysout file you are having, or whatever the utility, whatever the control D, or whatever the facility you have in your project, so we will be having that in the sysout, and whatever the program is writing, that report will be writing to that facility, that utility, or any particular file that we will be writing into the sysout dataset. So therefore, by using the sysout parameter in your DD statement, you are indicating that data set should be processed by JS2 or JS3, whatever your system is having. The sysout parameter specifies an output class associated with the dataset. Typically, class A is the class associated with an installation standard printer devices. If you code an asterisk star instead of an output class in the sysout parameter, the output class specified in the message class parameter of the job statement is used. Okay, so this is the syntax of a DD statement of a sysout dataset. So syntax is very simple. DD name, and then we have DD, then we have sysout equals to whatever you wanna give. So either you can give asterisk, either you can give A, or either you can give any particular utility, or you can provide a simple physical file as well, where you are writing your particular report. So sysout specifies a one character output class to be associated with sysout dataset. If you code an asterisk, the output class specified is the message class parameter of the job statement is used. So two ways to code the sysout parameter. The dataset identified by a DD statement of sysprint is JES sysout file with an output class A. So that's why they have provided sysout is equals to A. And another one, the INV RPT dataset is a JES sysout file with an output class that defaults to the output class specified by message class in the job statement. So that's why we have written it as asterisk. So whether you want to provide particular class A, or whatever you are having your class, you can provide that, or if you don't want to, then you can provide it as a asterisk. Then whatever your message class in the job statement, that will be attached to that particular sysout class. So that is how you can write the syntax of the sysout DD statement for that particular sysout dataset. So that's it for today. Yes, we have learned interesting topic. Firstly, we have learned about whatever the different types of record format we have. Then we discuss what is fixed block, what is variable length, what is variable length block, and then we discuss the undefined records. So in fixed, it is just having the fixed records. There is no concept of block, because it is whatever the record we have is equals to one block, and in the fixed block, whatever the block size we have is equals to whatever the block into the record length. So that is regarding the fixed block. And in variable length, we are having RDW, which is record descriptive word, which is 4 byte long in the variable block, and the length of variable record is different, it is not same. And in the fixed, it is having the same record, because it is fixed record, fixed length record. In variable, it is variable length record. So that is why the record's length is different. And in the variable block, we are having a record descriptive word, and also we are having block descriptive word. So this is how it looks. So we, at the starting of each block, we will be having BDW, and up at the starting of each record you will be having RDW. And undefined is very simple, that there is no internal structure for access method, it is just normal record. And then we have discussed some example. Then we discuss how DD statement of Instream dataset. Then we have learned the syntax of that Instream dataset. Then we learned the examples that we have for that Instream dataset. Then we went on learning how you can write the DD statement of sysout dataset, where we have discussed some example. So that's it for the fifth session. So I'll suggest everyone to whatever we have learned in this 5 lecture just revise all the topics, all the concept, and also practice what you have learned in this 5 session, so that in the coming lecture or whatever, when you are reading any JCL, you will get to know, okay, this is what what we have learned till now, and you can implement that knowledge when you are reading any JCL or when you are working on any particular JCL. So that's it all about today. Thank you so much.